This oscilloscope is based on Arduino Mega and uses an external analog to digital converter based on an 8-bit TLV571 chip. Here I'm going to first of all set the reference voltage for that chip, which is the supply voltage. Unfortunately, my USB has a supply voltage of 4.75 volts. So I'm going to set that up. The vertical scale is now set at 4.75 volts. The COM port for me is COM port 5. I've got a baud rate of 115/200. Junk weight 0, timeout never. It is possible to set a timeout which is different to that should you wish to. I'm now going to capture from the Arduino. Okay, you'll notice that 1000 readings have been taken in 1184.8341 kilohertz. That means that all the samples have been taken in 0.844 milliseconds. Now at the moment the Arduino doesn't know that it's got a supply voltage which is less than 5, so I'm going to send it updated information. I'd like to update the trig level. By default it will be positive. Okay, that's 484 millivolts, so it shouldn't trigger until there is a difference between 0 volts and 484 millivolts on a rising edge. Got it connected at the moment to a signal generator. I'm now going to run this. That means that data will be continuously sent by the Arduino. Try altering the frequency of my signal generator, decreasing it. Increasing it. I can also demonstrate that it's picking up the amplitude by decreasing the amplitude. It's operating on a rising edge at the moment, so I'll select negative trigger. So it should be operating on a falling edge. Let's put the amplitude back up again. Decrease the frequency. I can rescale the time base, applying some delay between samplings. At any stage I can freeze the graph. Apparently the signal generator is outputting at a frequency of 4.2 kilohertz. Unfreeze the graph. I'll end this fast run by selecting the select button. I can save the graph. It's saved to whatever directory you've got the oscilloscope in as scope.jpg, and copy the graph to the clipboard. Then save the data again it's saved to the oscilloscope directory as scope data.txt. The frequency button allows you, when you're not fast running, to get the frequency, not surprisingly. The other thing that's available is a signal on PWM3. So it's port 3, it's a pulse width modulated wave. If I connect that rather than the signal generator, to the input of the analog to digital converter, that's now picking up my pulse width modulated wave. Drop the delays off. The frequency that this wave is running at is 3.923 approximately. And the pulse width modulated wave that is actually being produced is nominally 3921 Hertz. So that's working correctly. That's about it.